Good morning, ladies and gentlemen. Welcome back. It's Mr. Chen for another lesson on MPM1D measurements, or three-dimensional shapes. Last class, or the last video, I think, was on the rectangular prism and the any right prism. I gave a formula for that. So today what we're going to be doing is looking at our last four shapes of volume and surface area. And so what we're going to be talking about really quickly, hopefully I can draw these out as fast as I can. Again, I also attached in the PDF the EQAO formula sheet. And again, those formulas are really good. So I'm just touching up on some concepts that we need to get through. Here we go. So with a cylinder, really quickly, looks something like that. And I'm not going to draw the net or anything. I'm just going to go through the shapes that a lot of you already know. That's the height and that's the radius of the cylinder. So the volume is equal to the base, in that case it's the circle, pi r squared, times the height. The surface area is actually the same equation that we talked about the prism, which is 2b plus hp. So there's two bases, in this case two circles, plus the height times its perimeter. And that's why the equation for this is 2 pi r h. You can actually factor out a 2 pi r if you really wanted to, and we actually have that equation. So that's the equation for a cylinder. For a cone, we're talking about a right cone, and I wish we could talk more about the history behind this. The volume actually happens to be 1/3 of the base times its height. And normally, if you were in class, I would actually demonstrate this by showing you the circle and actually how many cones it fills up to give its volume for a cylinder, but we don't have that luxury. Now, what's interesting, unfortunately, again, I'm not going to draw the net, but what I'm drawing here is the S, or the slant, and the surface area. If we were to unravel this, we kind of get like a tear shaped and a circle. So this actually happens to be pi r squared, that's that base, plus pi r s, where s stands for the slant. And sometimes you would actually have to find out the slant or something to find the height, and you would actually use, and some of you are noticing, I'll redraw it, where that's r, that's h, and this is the height, this is the slant. And so we have an equation, this right angle triangle, r squared plus h squared is equal to s squared. So that's the Pythagorean theorem that we actually can use sometimes. Sometimes we have to derive it and use it. Next, we get a pyramid. We're going to talk about only about square-based pyramids, because triangular-based pyramids, if it's not equilateral, as an equilateral base, then it's a little bit more challenging. Not saying you can't do it. So I'm just going to draw our pyramid. And again, it's a flat shape. So that's our square-based pyramid. I'm saying all the sides of the base of the square are equal. So the volume, and again, it's actually 1/3 of its rectangular prism. So 1/3 base times height. The surface area, this time, I think some students find it easier. We're going to do it this way. We're going to call this b squared for the area of the base, because it's a square, plus 4 triangles. 1/2 base times height, where the height of the triangle, in this case, I'll draw this in blue. That's this h. Right? And this b, of course, is that side length b. So I'll put this b there, put that b there. So this is the area of the square. And this are 4 triangles, and they're all congruent, times the area of the triangle, right? Where h is a slant. So I think that's okay. And finally, we have a sphere. And this one actually is the neat one. And again, I would like to show you a video or animated GIF, and you can research this clearly. Hopefully I'll find a link for it. It actually shows how we actually can derive the equation for this. The volume actually is 4/3 pi r cubed. Notice out of all the equations, this looks scary, but actually there's only one variable, unlike the other ones. And the surface area, if we were to unravel it, and again, it seems weird why it is so, but it's 4 circles. So 4 pi r squared. So those are the 4 equations that you need to know. So here we have 3 questions that I think I've posted. Maybe or maybe not. If you need to pause the video, please feel free to. I stole these questions from the Math Power, and we're just going to take a look at maybe just 2 questions. Question 13. It says, question 13 says, calculate the surface area and volume of the hemisphere to the nearest square or cubic meter. So we have a hemisphere, it's half a sphere. The volume actually is going to be pretty easy, I think, to solve. So let's just do that now. This pen is a little too thick. So number 13. So volume is equal to half of 4/3 pi r cubed. Doing some math. Half of 4/3 is actually 2/3. Substitute the 6, which is being cubed. And we get an exact answer, what's called 144 pi cubic meters. 144 pi cubic meters. 6 cubed is 216 times 2 divided by 3, 144. So this is called an exact answer. The approximate answer for question 13 is, using our pi button, it's approximately 452.38 cubic meters, and they said to the nearest square or cubic meter, so 452 cubic meters. Now the surface area, it is still the half of the unravelment, so half of the 4 pi r squared, right? But that is in the outside, and again, you got to remember, if I shade in the red part, we're missing this particular circle, right? Because that is called the covering, right? So we still have to add another circle. So half of 4 is 2. 2 plus 1 is 3, so 3 pi r squared. So we're not memorizing this equation for a hemisphere. It just seems to be the one that we have. And again, 3 pi times 6 squared. And the exact answer is 108 pi centimeters squared. Nope, not centimeters. Meters squared. And therefore, the approximate answer is 108 pi 339.2 approximately meters squared. But again, they wanted the nearest point, so 339 meters squared. So those are the answers for question 13. I think actually maybe 14, 15 you can figure on your own. And as always, feel free to look at the CEMC courseware or use your textbook as a resource. And you're more than welcome to email me. Thanks for watching. Have a nice day.